Hi guys, apparently I forgot to do the video for section 2, so here goes. So we can calculate moles of a substance if we know its mass or if we know its volume. And so we're going to have, as you already know, conversion factors for that. I hate those games where they make you guess how many things are in the jar. I have no way of knowing. That's because scientists do it with much more precision. So, how do you convert between the mass of a substance and the number of moles of a substance? Well, to do that, we use molar mass. And so molar mass would be something where we go to the periodic table, we look up the mass of that element, and then we multiply by any subscripts in the formula. So in particular for oxygen, which is O2, one of our 7 diatomic elements, we would take 16 times 2 to get 32. And again, we're going to use the numbers that are on our periodic tables, not the ones you see in this PowerPoint. So make sure you're writing the formula for the substance rather than just a name, and that will help you remember. Also on your note card, you should have the 7 diatomic elements, and those are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and lastly, iodine. So, use the molar mass of an element or compound to convert between the mass of the substance and the number of moles of that substance. And so we can write that ratio either with mass on the top and moles on the bottom or the reverse. And we're going to make sure that we always use it in such a way that we make the units cancel. So if we're given moles, we would use this one. If we're given grams, we would use this one because that would make the units cancel. Items made out of aluminum, such as aircraft parts and cookware, are resistant to corrosion because the aluminum reacts with oxygen in the air to form a coating of aluminum oxide on the outside. This tough resistant coating prevents any further corrosion. What is the mass in grams of 9.45 moles of aluminum? So, our given is 9.45 moles of aluminum. Our conversion factor is going to be the molar mass of aluminum, and we should come out in grams. And so we're going to make sure that the moles cancel. Oh, and here they're calculating the molar mass. And so 2 times 27, which I think ours is 26.98, 3 times 16.00, and so we'll get a slightly different mass, and we can do it all in one calculation. Now we can use this to cancel out, and our conversion factor will have moles on the bottom and grams on the top so that we get the correct answer in the end. So, when iron is exposed to air and corrodes to form a brown rust. Rust is iron 3 oxide. How many moles of iron 3 oxide are contained in 92.2 grams of iron 3 oxide, Fe2O3. So we need to know the molar mass of Fe2O3, and we're going to add that up, and we're going to use this so that we're dividing by the molar mass this time instead of multiplying, and come out in moles. You know how many grams of a substance you have, and you want to find out how many moles this is, then you would need what to calculate it? Well, you'd have to find the molar mass. And of course, you're going to take care of those subscripts and you're going to use the mass of the elements on the periodic table. Whew. So, the other calculation, and we went over it today in class, is how to do molar volume of gas at STP. And again, these will always be at STP. And so here we have mothballs or glucose. Oh, these are glucose and mothballs. And we have 1 mole of liquid water. Each one of these have different volumes because they're solid in the liquid state. But when we have gases, they all occupy the same volume at STP. So it doesn't matter what the element is. They will all, 1 mole of any gas will be 22.4 liters. So this is Avogadro's hypothesis, and I believe this is one of your vocab words, so you should make sure you know that. I'm not going to read to you. The particles that make up gases are not all the same size. However, the particles in a gas are very far apart, and therefore the volume is mostly empty space, and we assume that the particles really don't occupy very much volume. And so they all occupy the same volume at the same temperature. So they may be moving. So whether the particles are large or small, and they all have vast expanses or largely empty space between those individual atoms. And so this is an exaggeration of the size versus the space in between them for sure. So at standard temperature and pressure, which means 0 degrees Celsius and 1 atmosphere, which you don't need to know. But if you wanted, and you do need to know what standard temperature and pressure is and what values it has, but it's not like you have to calculate anything. That's a definition that you need to know. And it says that 1 mole, or 6.022 times 10 to the 23rd particles of that gas will occupy 22.4 liters. And it is called the molar volume of a gas. So again, that is a vocab word. And so I can use this conversion either multiplying to get liters or dividing to get moles. So you can convert any gas and you don't even have to know what gas it is. Sulfur dioxide is a gas that is produced by burning coal. It is an air pollutant and one of the causes of acid rain. Determine the volume in liters of 0.60 moles of SO2 gas at STP. So I know this is going to be a molar volume question because it's asking me for volume. It mentions liters, and it also mentions that it's a gas and it's at STP. So those are all of your clues that this is going to be a molar volume question. And so we're going to use our conversion factor of 1 mole equals 22.4 liters. Our known is that we have 0.60 moles, and what we want to find is liters of SO2. So our conversion factor is there. We're going to multiply by 22.4, and we get 13 liters. How to calculate the moles of a substance given its mass? Well, we're going to use how can you calculate the moles of a gas in a given volume at STP? This one will take 2 conversion factors. How do I know that? Well, I'm starting with volume, and I want to get all the way to mass. And the things I have, volume I can relate to moles, and then moles I can relate to mass. So I know I need 2 conversion factors. And you should be able to look at your chart and predict that for yourself. So you're going to calculate the molar, you're going to get the molar mass, and you're going to use the 20 molar volume as your other conversion. So we're going to stop here for just for this video, and I will come back to you in just a minute. Thanks for listening.